Hello viewers, in today's session we are going to discuss another important and very conceptual problem from definite integrals, right? And in this session we are going to discuss this problem where we are given a function f from closed interval 0 comma 5 to the set of real numbers, and this function f is given to be continuous, right? And moreover we are given that the value of the function f at x is equal to 1, that is f of 1 is equal to 3, and we are given another function phi of x, which is defined as phi of x is equal to integral 1 to x t cube g of t dt, where g of t is defined by this expression, that is g of t is equal to integral 1 to t f of u du. Then we have to find out the value of phi double prime of 1. So viewers, let us see how easily we can solve this problem by using a simple concept from definite integrals, right? See, we know from the theory of definite integrals that if we have a function, say capital f of x is given by the integral a to x f of t dt, then if we differentiate f of x with respect to x, then we get f prime of x is equal to f of x, right? So this is a famous theorem in definite integrals. If we are given a function capital f of x is equal to the integral a to x f of t dt, then the derivative of f of x, that is f prime of x, is equal to the function f of x, right? So here we are going to utilize this concept, and moreover here we can also use the concept of derivative. So now let us start with this function phi of x. So we are given phi of x is equal to integral 1 to x, and here we have t cube g of t and dt, right? So let us differentiate both sides with respect to x and using this concept. So now let us compare this integral with this one. So here we have x, here also we have x, and here we have 1, here we have a. So a can be taken as 1, and this function can be taken as f of t. So f of t is t cube g of t. So if we differentiate both sides with respect to x, then due to this result, we can get phi prime of x is equal to f of x, right? And here we have f of t, so this is f of x, and f of x can now be written by replacing this t by x. So we have here x cube, and then we have g of x. So we have obtained the derivative of phi of x. Now let us differentiate both sides again with respect to x. So now we have phi double prime of x, and here we have d by dx of x cube, and here we have g of x. Now in order to differentiate this function, we can see that this is the product of two functions, right? So using the product rule, so here this function x cube can be taken as u, and g of x can be taken as v. So we have first function, that is x cube, then the derivative of g of x, and then we have g of x and derivative of x cube, right? So phi double prime of x is now x cube, and the derivative of g of x can be written as g prime of x, and here we have g of x, and the derivative of x cube is 3x square, right? So now we have obtained the expression for the second derivative of phi of x. Now we have to find out the value of phi double prime of 1. So replacing this x by 1, we can now write phi double prime of 1 is equal to 1 cube, taking x is equal to 1 in this expression, and here we have g prime of 1, then we have g of 1, and here we have 3 times 1 square, right? So 1 cube is 1, and we are left with g prime of 1, and here this is also 1, so we have 3 times of g of 1, right? So to get the value of phi double prime of 1, we need to find out g prime of 1 and g of 1. So now consider this function g of t. So we have g of t is equal to 1 to t, and here we have f of u and du, right? And again, if we differentiate both sides with respect to t, then we can get g prime of t is equal to f of t, again using this result, right? Here we have f of x, here we have g of t, and then the integral a to x, here we have 1 to t f of u du. So differentiating both sides with respect to t, g prime of t is equal to f of t, right? Now see here, t is a dummy variable, so we can replace this t by x also. So we can now write g prime of x is equal to f of x, right? And here we have g prime of 1. So if we replace x by 1, then we have g prime of 1 is equal to f of 1, right? Taking x is equal to 1 in this expression. So g prime of 1 is equal to f of 1, and from here we can see that in the given problem we are given the value of f of 1 as 3. So here we can take 3. So g prime of 1 is equal to 3. So here we can replace g prime of 1 by 3, and then here we have 3 times g of 1, right? So now we need to find out the value of g of 1. So again, taking the help of this expression, we can find the value of g of 1. Now see, if we replace this t by 1, right? Or before replacing this t by 1, we can also write this function as g of x is equal to the integral 1 to x and f of u and du, right? So if we take x by 1, or replacing x by 1, we have g of 1 is equal to integral 1 to 1, taking x is equal to 1. Here we have f of u du. Now we can see that both the limits of integration are same or identical, so the value of this integral must be equal to 0, right? So g of 1 is equal to 0. So here for g of 1 we have 0. So now this is 3 plus 0, that is equal to 3, right? So the value of phi double prime of 1 is equal to 3. So viewers, this is how we can easily solve these kind of problems using this concept.